Good morning. I'm going to do the practice problems for chapter 1. I hope this helps you out and let me know if you have any questions. So let's begin. So number 1 asks, a cardiologist is interested in the mean recovery period of her patients who've had heart attacks. Define the following in terms of the study and give examples when appropriate. So for this one, I need to look at the population. So the cardiologist wants to know the mean recovery time of her patients who've had a heart attack. So she would want to study all of her patients who have had a heart attack. So the population is all of the cardiologist patients who've had a heart attack. It's not a group of them. And we're very specific because she said up here she only wants people who've had a heart attack. So the sample is a smaller percentage or proportion of the population. So here, if you keep looking down, I want it to say a group of instead of all. So here I can see the sample is a group of cardiologist patients who've had a heart attack. So again, I'm taking a part of the whole from up here and doing my study on it. Okay, so parameter means the characteristic of the population. So she wants to know something that would affect all of her patients. So I'm not going to look at the ones that say group because that doesn't matter. I want to know all. And I'm not really worried about the age because she didn't care about that. She wanted to know their recovery time. So it's going to be this one. The parameter is the average recovery period for all of the cardiologist patients who've had a heart attack. Okay, so let's look at D. The statistics means that is the characteristic of the sample. So let's go back up and look at that sample. The sample was a group of cardiologist patients who've had a heart attack. So I want to know the statistic based on that sample. So remember, I'm talking about a group, so I'd want to know the average recovery period for a group of the cardiologist patients who've had a heart attack. Not for all their ages or a group or all of the patients. I just want part because it's the statistic which talks about the sample. All right, the variable is what we are going to study. And that's really what you're collecting the data on. So she wanted to know the average recovery time. So the variable is the time that it takes to recover from a heart attack. All right, so let's see this. So part F is like, what would your data look at? Well, the first part, you don't care about their ages. Second, you don't care about how many patients you have. 30 to 45 minutes, that's not how long it takes to recover from a heart attack. That might be how long you had a heart attack for. So an example would be 2 to 3 weeks. All right. So that's how you do those kind of problems when you're in 1.1. All right. So here's another one. Number 2, a Lake Tahoe Community College instructor is interested in the mean number of days Lake Tahoe Community College math students are absent from class during a quarter. So she takes this sample and produces a mean number of days absence as 3.5. What is this an example of? Well, let's think about it. So she took a sample of all of her classes. When you're talking about a sample and you get a statistic from it, that's what it's called. It's called a sample statistics. That's something that you've gotten from the sample that you can talk about or give the information out about. Okay. So let's look at this. This is about data types, and this one can always be very, very confusing. And I just want you to remember, quantitative discrete means it's something that you can count or measure, and it tends to be in whole numbers. Quantitative continuous is something you can count, but you can have decimals and fractions included. Qualitative is just categories and names. So let's look at number 3, time in line to buy groceries. So you can be in line to buy groceries for 5 minutes and 7 seconds, for 10 minutes and 25 seconds. So that's quantitative continuous because you can have seconds into it, you can have hours, you can have minutes. So if I go down here, can I give an example of the data? Well, 9 people in line is not a timeline. Neither is 3 gallons of milk, neither is a bottle of soda or 5 grocery carts. It's 7.2 minutes. That is the correct type of data that you would use. So for number 4, identify the type of data which would be used for this one. Most watched TV show. Okay, they're looking for TV show names like The Walking Dead, Game of Thrones. So that's going to be qualitative because I can't really add The Walking Dead to the Game of Thrones and come out with some mathematical number. So give an example of the data. Well, I don't care about how long TV was viewed for, or the number of televisions or seasons or how many viewers. I just wanted the name because that's what this data up here, most watched TV show, was looking for. So, all right, let's keep going. All right, so number 5, a study was done to determine the age, the number of times per week, and the duration, amount of time of residents using a park in San Jose. The first house in the neighborhood around the park was randomly selected, and then every eighth house in the neighborhood around the park was interviewed. What sampling method was used? All right, there's a huge key in here that you need to look for. So they started one house randomly, and then they went to every eighth house. That's systematic because when you have a number like 8th, 5th house, 10th house, that means you're systematically counting out and going to the ones that you count out for that certain number. So that makes a systematic sample. All right. So number 6 deals with frequency distributions. And I know this can kind of be tough, but if you kind of understand them, they'll make sense. All right. So this table right here has some errors in it. And what it's looking at is 19 immigrants to the U.S. were asked how many years to the nearest year had they lived in the U.S. And here's the data. Well, this is the frequency distribution that was made. And down here, they want to go ahead and say, all right, let's fill in. Let's try to correct everything that was wrong with it, okay? So you'll just need to go through and make sure that you get what was wrong through. Okay, so let's look at the first one. All right. So for this one over here, cumulative relative frequency is when you add all of these up and get this right here. So if I add, let me bring up my calculator. Oops, sorry about that. Okay, let me bring this up. All right, so let me turn it on. So I'm going to do 2 divided by 19 plus 3 divided by 19 plus 1 divided by 19. I'm just doing it in the calculator. There's 2 to 3 to 4 other different ways to do this. I'm just showing you the easiest that came to mind for me. 3 divided by 18. Why am I doing this? Because I'm adding up all my relative frequencies. So if I do that, I get the answer of 0.4737 because it wants 4 decimal places. I don't know if you got to see that. Oops, not that. Sorry about that. Sometimes my calculator didn't want to come up. So yeah, that's what I got. All right, so down here, it's missing data. So how many people, let's see, were here 15 years? So if I go up here, I see 1, 2. So I have 2 people that were 15 years. Okay, and while I'm doing that, let me go look at 20. How many people were 20 years? Oops, go right here, and I see 1, 2, 20 years. Okay, so I have 2 people who that way. All right. So now I can fill in my data. So I'm going to I'm going to just make this as a decimal to make, well, I can do it this way. Just do this. That might be easier. WebAssign realizes that that is a fraction. So I did 2 for this one, 2 over 19, because 19 is my total sample size, and 2 is the number that occurred at 15 years. Same down here for 20. All right, I need to come in here and fill it out. Well, another way I can solve this problem, and I'm going to bring up my calculators to show you, is I know this one right here was 0.7895, and I can add 2 divided by 19 to it to get the cumulative relative frequency. So this one then is going to be 0.947. 947. Okay, so that's what I got right there. And you can round up or down. It doesn't really matter. I think there's a good level of decimal that they'll give you a certain amount of leniency with it. All right, so let's go down here and start answering questions. All right, it says explain what is wrong with the statement. 47% of the people surveyed have lived in the United States for 5 years. All right. So what is wrong with this? So it's saying that it's saying 47% of the people have lived for 5 years. And really, there's no way that can happen because I'm looking at, it's making me look at the relative frequency because it's saying, okay, 47 of the people lived at 5 exactly. So that's what's wrong with that. Because if you see right here, I only had 3 people that did that. And even 47% of the people, they lived here for 5 or less, not just 5. That's what your cumulative relative frequency is telling you. So that's what's incorrect about that statement. So it says fix the statement to make it correct. So I just talked about this. 47% of the people surveyed have lived in the US for 5 or less. And if you look here, here's 0.4737 and below. So I could say 47% of the people have lived in the US 5 years and below because they lived here 5, 4, 2, and 0. All right. That's how you do those kind of problems. All right. So let's do part D. What fraction of the people lived in the United States for 15 or 5 years? All right. So let's look. What was 15? Let me bring out my calculator. Okay. 15 was 2.9. Oops. Let me do this. Oops. 2 divided by, excuse me, 2 excuse me, 2 divided by 19. Oops. Plus, all right, that was 15. Let me look at 5. So that's 3 divided by 19. Okay, all I'm doing is I'm adding 2 right here for 15 and 3 right here. And I just went ahead and did it as a relative frequency. You can do it as 3 plus 2 gets 5. 5 divided by 19 and get your answer. That's just what I did right there. So how many people, you can do it as a decimal, or probably the easiest one to do is just do 5 divided by 19. Okay. Next one, what fraction of the people surveyed, have lived in the US at most 7 years? So what does that mean if I say at most 7 years? So that means the most they could live there was 7 years. Okay. So let's look at that. All right. So I just need to go ahead and start counting. So let's do this. Okay. So I'm going to go at most 7 years. I'm going to go 2, 5, 6, 9, 11. So it's going to be 11 over 19. Okay. That's all I put in. All right, how about if they lived here for fewer than 7 years? Okay, well, it's kind of tricky. Which one am I going to use for that one? Well, you got to think about it again. So I want under 7 years, right? I don't want to include 7 years. I want under it. That's different than what we just did because I didn't say fewer and including 7 years. I've got to do everything under 7 years. So I'm going to do 2 plus 3 is 5, plus 1 is 6, plus 3 is 9. So 9 over 19. Because remember, I cannot use the 7 into that, the 7 years. It's not allowed because I wanted fewer than 7. All right. What fraction of the people surveyed lived in the U.S. from 5 to 15 years? So I'm going to go here to here. So I'm going to go 3 plus 2 is 5. Plus 2 is 7, plus 2 is 9, plus 2 is 11. So my answer for that is 11 divided by 19. As you can see in WebAssign, you can put your fractions as this way. It's fine. If you want to put them as a decimal, they might kick it out because it's asking for the fractions, but I don't think it will. Just practice with these. I know they're kind of confusing, but once they click, it's a really easy way to understand the material. I hope this helped. Thanks.